What's up everybody, now we're going to look at some LMI techniques, and this lemma is called reciprocal projection lemma, and in the previous video we talked about projection lemma. So this is a specialized version of it, and I got this from a textbook, and the name of the textbook is Duan and Yu, LMIs in contour. And also this specific theorem, I got this from Apkarian 2000 and a paper in CDC, okay, conference, and okay, vision and contour. Okay, and so what this theorem says is the following: we have a E positive definite matrix, and the following are equivalent: this expression and this expression, which is to say there exists W, which is a matrix Rn by n, and we can find W which satisfies such that this inequality is satisfied. Okay, so let's this is condition 1, and we will, this is if and only if condition, and this is condition 2, right? So what we need to do is to prove condition 1 implies condition 2, and condition 2 implies condition 1. Okay, so let's check that. But when you first saw it, like in the previous projection lemma video, it like there are so many, it feels like there are so many like variables, and I got it, I have that type of uncomfortable feelings, but let's not focus on that, and let's just use the simplest ideas. Okay, so let this theta, like capital theta, phi and psi, right, matrices are given, okay, like that. Then we can easily verify. Okay, so far we haven't assumed anything. Okay, we just like defined 3 new variables. Okay, then we can easily verify that, like right orthogonal complement of phi is this. Okay, how can we write that? Like using the definition. Okay, again, so far we haven't assumed anything, right? Like this comes from the definition. All right, and the right orthogonal complement of capital psi matrix is this. All right, got it. So far we haven't assumed anything. Furthermore, we can show that like, can you see it? Do I need to zoom it? Yeah, yeah, it would better if I zoom. All right, it looks better now. Okay, so furthermore, we can show that this is correct. Why? Like, just substitute like right orthogonal complement of phi with this, right? And using the, I don't know, like their explicit expressions, and we can just find that, we can just obtain minus p inverse, right? So let me show that. This 0 p inverse, okay, since p is symmetric, right? I will not bother about that. Capital psi plus p is transpose s minus p, and what's right orthogonal complement of capital phi is that, okay, explicitly. So let's, for the argument's sake, calculate that, and this is right. Okay, and identity. So let's multiply these two matrices, and what we have is that. Okay, so what I'm trying to say is that when you explicitly write the terms, and you can just obtain that, right? So we haven't used any mathematical tricks or anything. All right. So we have that, right? And okay, I think there might be a mistake or something. What's going on? Okay. It's redundant. Maybe just ignore that. Yeah. So let us look at condition 1 implies condition 2, right? So which is to say we know that this is correct, this is true, and we want to investigate if there exists W such that this inequality holds, meaning this LMI is feasible with respect to W. This is another way of saying that. Okay, so we know that, and by using some algebraic manipulations, we will try to obtain that expression. Okay. Okay, this is what we know, right? And let's like manipulate the p variable, right? We haven't done anything again, and this is what we have. Why? Because like we just use the expression that we have written, right? So no tricks, and here this part is important, and this is the projection lemma, and which we have covered in the previous video. So from this, if and only if condition, we can obtain that inequality. All right, I will not talk about the specifics of the projection lemma, okay, because we have covered that already. All right, so far we know that. All right, and by explicitly writing the terms like capital theta and phi and psi, we can obtain this inequality. All right, so what we have done is we have that which is given in the condition 1, and by using algebraic manipulations we were able to construct the condition given in like item number 2, condition 2. Okay, and so 1 implies 2, right? What we have is, or what we want to prove is 1 if and only if 2, right? And so far we have proven condition 1 implies 2, right? And now we need to prove condition 2 in fact implies condition 1. Okay, I should do that. So we need to look at that. All right, let's clear some. All right, condition 2 implies condition 1. Okay, which is to say we know that this LMI is feasible with respect to n by n matrix W, right? And we want to investigate if that condition is true. All right, so this is what we have, right? And we can like implicitly express that condition by using the like explicit definition or definitions of theta, phi, and psi, right? So we can write that, write the expression in that form, and by using again the projection lemma, we can, if by using if and only if condition, we can write that, and by using this equality, we were able to obtain, and in the previous step we can obtain that. And since we know that like p is positive, which is given in the problem, which is something that we know, and we are able to construct this condition, which is given in condition 1, right? So that's it. Like, it is like, this is from a paper, CDC in 2000, and this was about a control design for to minimize H infinite norm, right, of some system. Like, we have some controller block, and this is like exogenous noise, and this is objective, right? What we want to, okay, what I'm talking about is has nothing to do with specific lemma, right? But I just wanted to make something clear and design a such that is minimized. Okay, so what I'm trying to say is that this lemma is used in this problem, okay, and which is covered in a paper in CDC in 2000, right? I will include the related details about that. So, right, let me delete all of them, and that's it, and thanks for watching.